Okay, guys, we're going to be looking at IXL S5, which is area and perimeter in the coordinate plane, and I'm going to run through a few of these with you guys. This first question is asking about area of a square. So I've got a couple of options here. When my figure is on the coordinate plane and each side is perfectly horizontal and perfectly vertical, where there are no blocks cut off, I can actually count the blocks inside this figure, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, all the way through to find that area, because area is how much is on the inside. Or I can use the formula for this, and I'm saying square could be rectangle. I actually have not counted this yet. But I can also do length times width or base times height, however you want to think about that. So that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 on the base. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it is a square on the height. So 10 times 10, there's going to be 100 blocks in here, making the area 100 square units. Same thing for this, because it's perfectly horizontal, perfectly vertical, no cutoff squares. I would say this is 1, 2, 3, 4, 5 on the base. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I think 16 on the height. And so I'm looking at 5 times 16, or 80, as the number of blocks inside here for my area. This one is all about perimeter, and so I'm literally just going to count around. Remember, perimeter is how big it is around, and so I'm just going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 here, which means I'll have 15 here. I might forget this. And I could be subtracting my y values, and I'm about to talk about that. But I'm wanting to show you that when it's perfectly horizontal and perfectly vertical, you can just count. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So what I could do instead of count is I could subtract. So, for example, this point right here is 5, 6. And this point right here is negative 10, 6. Okay. And so what I can do is, to find this length, this runs along the x-axis, so I could actually just subtract my x's. That would be negative 10 minus 5. And I'm going to take the absolute value. We've done this before, because length is never negative. And so this would give me negative 15, and then I would take the absolute value of it, and that would give me 15. Okay, so there's that 15. And I can do the same thing for this length. So this point down here is 5, negative 8. And this vertical length runs along the y-axis, so I would subtract my y's. So that would be negative 8 minus 6. And I take the absolute value. This would be negative 14. Absolute value of negative 14 is 14, right? So that's where this 14 is coming from, here and here. Okay. So then I'm just going to add 15 plus 15 plus 14 plus 14, and that's going to give me a perimeter of 60 units. Oh, I can't count. I should be, yeah. Sorry, I counted in my head and I miscounted and I counted to 60 instead of 58. See, this is why we should use a calculator first thing in the morning. Okay, so next thing we're looking at here is a triangle, and we're wanting to know the area of this triangle. And so we need to remember that the area of a triangle is 1/2 base times height, or you can think about it as base times height divided by 2, however that makes the most sense to you. So my base in this case is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 units it looks like. And I could double check that by subtracting 9 minus -8, which ends up being 9 plus 8, which is 17. And then my height is 1, 2, 3, 4, 5. And so I could do, looks like 7 minus 2, which is 5. And so in order to find the area of this triangle, I would do 1/2 times 17 times 5. Let's see, 17 times 5, whoa, is 85. And, oh, first thing in the morning, wow, this is 15, should definitely be a 5. There we go. So I said 17 times 5 is 85. And then half of that is 42.5, and I'm feeling nervous now. 42.5. All right. Area of a rectangular figure, or in this case a square figure, is just base times height. So 1, 2, 3, 1, 2, 3. 3 times 3 is 9, or I could just say 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 blocks. Perimeter, count around. I'm going to skip ahead. Looks like another perimeter, count around. Skipping ahead. Oh, all the way into the 90s. So that pretty much looks like it then. This looks like an extra easy one where you don't have to do any distance formula or anything like that to get the answer. In fact, this would be an easy one to go to 100 because you could just easily graph these points and find the area and perimeter. So good luck, guys. This is your last one before spring break. Enjoy your break, and I'll see you on the other side.